Okay, let's go.
All right, welcome back to class. We want to look at another topic. What you have here is variation. Now, when we talk about variation, we're looking at the relationship between two quantities or two variables or two or more variables. Okay, so we want to know how, let's say, x relates with y. That is where this term variation comes in. Um, at some level in mathematics, we call variation proportion. Okay, so I'm relating two different quantities or two or more different quantities. And know how the increase in one can lead to a decrease in the other, or decrease in one leading to an increase in the other. Okay, so basically when we talk about variation, there are four types of variation at O level. We have what we call our direct variation, we have what we call our inverse variation, what we call joint variation, and we have what we call partial variation. All right, this class is specifically for students that are in junior secondary school. So we won't be touching partial variation. Our concentration in this class would be on the first one, direct variation, second one, inverse variation. Then lastly, we look at joint variation. Let me start from the first one, direct variation. Now, in direct variation, we try to compare two quantities. And in the comparison, an increase in one quantity, say x, leads to an increase in another quantity, say y. Decrease in x can also lead to a decrease in y. That's what they refer to as direct variation. Now, when we're dealing with variation, we use this sign, and when we remove this sign, we introduce our equality sign and then a constant. Remember, your constant mustn't be k. You can use the letter as your constant, but let it not be the same letter with any of the letters already used to represent other known quantities or known quantities. Okay, so as to avoid confusion at the long run. Okay, so I've removed this sign of proportionality and I've introduced our equality sign and then our constant. Okay, so I can now say that x is equal to ky. Okay, so let's have a question and see how we can solve questions that involve direct variation. Now remember, an example of a direct variation is if we have a school and you say that the salary of a staff in the school is, let's say, 80,000 naira. Now, if you have 10 staff in the school, that means you're going to be paying 80,000 multiplied by 10. That's 800,000. Now, if you increase the workforce by, making the workforce now from 10 to 100, increase the workforce to 100, then automatically the salary is going to increase to 8 million. So you see that there's the number of the workforce and the number of staff, increases. So the salary, the cost of paying them in the school. That's an example of what we refer to as direct variation. The increase in this now will lead increase in, provided the salary remains the same, the increase in the number of staff will also lead to the increase in the amount of money the school will spend, managing the staff or keeping them. All right, so let's take a question from here and see how this works. Given that x varies directly as y, x is equal to 5, y is equal to 10. Okay, now calculate the value of y when x is equal to 4 and x when y is equal to 6. So we have the value of y when x is equal to 4, y is not known. Okay, and when y is equal to 6, x is not known. So this is the kind of thing we have here. Okay, first of all, in solving questions involving variation, we need to get what we call the formula or relationship by using the first, sentence given to you, or the values of the unknown, or the variables given to you. Example, in this case now, where we have that x varies directly as y, and now you can say that x is equal to ky. You've removed this and you replace it with your equality sign and a constant. And we went ahead to have that when x is 5, y is equal to 10. Okay, so here now you find the value of this constant by dividing this by 10. When you do that, we have 5 here, we give you 1, 5 here, we give you 2. So we have that k is equal to 1/2. Then come back to this place now, where you see your k, you replace it with what? Half. So you have k is equal to half y. You can also write this as x rather is equal to y/2. Okay, so this now becomes your relationship between x and y. So this automatically is what we call the relationship or the formula for this particular question. So you can call this equation star, or maybe equation 1, anyhow you want to do it. So when you've arrived at this point, it's very easy for you to solve the remaining parts of the question. So the first one is calculate y when x is equal to 4. Calculate y when x is equal to 4. So coming to this place now, you already have that x is equal to y/2. Now when x is equal to 4, when you see this, you test this, then over 2, you cross multiply. Okay, from here now you have that your y is equal to 2 times 4 will give us what? 8. So y is equal to 8 when x is equal to 4. All right, so let's do the last one. The question is calculate x when y is equal to 6. X when y is equal to 6. Okay, so from here, I now, we already know that x is equal to y/2. This is a formula. So when y is equal to 6, x is equal to 6/2. Okay, so from here now, we have that x is equal to 6 divided by 2 will give you 3. So our answers here are 8 and 3. Okay, all right, that's a question in direct variation. All right, let's look at the next part. Now the second example says, if the frictional force F in Newton acting on a moving vehicle varies directly as a square of the speed. We have F varying with the square of the speed. Okay, write down the relationship between F and V. The relationship between F and V. Of course, then given that F is equal to 300 Newton and V is equal to F is equal to 300 Newton, then V is equal to 10 km/h. Okay, so let's first of all take that. Let's get the relationship between F and V. Now from here, we have that F is equal to kv squared. Now let's substitute these values or replace these the way they are. So here now we have 300 is equal to k times what is our V, 10 squared. So here we have 300 is equal to k times 100. Divide both sides by 100. Okay, this cancels out this, and we have that k is equal to 3. Okay, so we have that k is equal to 3. Come back to this place. Since we have that F is equal to kv squared, where you see k, you put 3. That's, you substitute the value of here now. So here we have that F is equal to 3v squared. Now this becomes the relationship between F and V. Okay, so this will guide us to solve question I. Question I says the speed when the friction is 600 Newton. The speed when the friction is 600 Newton. So we have that f is equal to 3v squared. Okay, so since f is equal to 600, you place 600 here is equal to 3v squared. Divide both sides by 3. 3 we cancel out 3 here. 3 here will give you 1, 3 here will give you 2. So from here now we have that v squared is equal to 200. So v squared, or square both sides, and you end up having, need the square root of both sides, you end up having that v is equal to 200, square root of 200. So v here is equal to 14.14. 14.14 kilometer per hour. All right, let's take the next part. I. V is equal to 1 kilometer per hour and F is unknown. Now remember we have a formula already. F is equal to 3v squared. So from here we have that F is equal to 3, V is 1 squared. So F is equal to 3 Newton. Very simple. All right, so this is the kind of thing you do when you have questions relating to direct variation. All right, if you have any challenge or any question at all here, you can just post it using for those of you that are in STEM Kids e-learning community, just make your comments here, or maybe ask your questions. If there's any challenge you're having, you can just ask your question, then we move on. All right, let's look at the next part. That is inverse.